modeling variation. And it's basically taking these phrases in English and translating it into equation. So here we have the equation right here. And that equation, y equals 4x. But more general, it's like y equals k, some constant times x. And in this case, the constant is 4. We say that y is proportional. Proportional would be the answer there. So when y equals kx, then y is proportional to x. And the constant of proportionality is 4. Okay, this is directly proportional. Directly proportional. Okay, here in the second one, we have y equals 4. We have y equals 4 over x, or y equals k over x. So 4 is a constant, and it's k in this case. Here, when this one is in the denominator, then it's inversely proportional to x. And the constant of proportionality is 4. Number 3, if you have, so here you have 3 different variables. So basically z is equal to kx over y. Now when you have this situation, you're only going to have one constant, okay? Even though there's 2 variables here, there's only going to be one constant, because you get 2 constants, then you could just be absorbed into one constant. But k is directly proportional. And inversely proportional to y. Okay, because y is in the denominator and x is in the numerator in this case. Okay, so let's look at number 4. If z is directly proportional to the product of x and y. Okay, so if you're just looking at just this part right here, it's directly proportional to the product of x and y. The product is x times y. So that's the kind of situation that we're going to get right here. Z equals kxy, because it's directly proportional to the product of x and y. So k is our constant of proportionality. Okay, then the second part says z is 10 when x is 4 and y is 5. So that means we're going to replace this with a 10, and the 4 and the y, x gets replaced with a 4, and the y gets replaced with a 5. Okay, so the x, y, and the z are variables. They can take on different values, but they're kind of restricted. Okay, so if this is 4 and that's 5, then that has to be 10. Okay, and then so generally, this is the first step of it, is realizing that there is a equation where these are related. The next step is like putting some values in. The next step would be finding k. Okay, so we have 10 is equal to 20k, because 4 times 5 is 20, and then you divide both sides by 20, and you get k as 1/2. Okay, and so then what you do is you place this 1/2 into here. Okay, so this 1/2, when it substitutes in for k, so z is equal to 1/2 xy. Okay, so the answer here is 1/2 xy. Okay, so that's kind of an introduction. Let's go to some more problems. Number 5. Write an equation that expresses the statement. P is directly proportional to W. Okay, so that would be P equals KW. That's directly proportional. Write an equation that expresses the statement. Z is inversely proportional to V. So Z is, and Z equals, inversely proportional to V. That would be K over V.
I have a quick question on number 5.
Yes.
Can you I just typed it into Webassign and it said it was incorrect. Is there something, I just said like P equals sign KW. Is there something else to like add to that?
Did you use a capital P and then small k and small w?
Oh, there it goes. Okay, thank you. I was a little confused on that. Thank you.
Okay, so it is sensitive to lower and uppercase, right? It seems like that's interesting. Okay. Okay, number 7. Write an equation that expresses the statement A is proportional to the square of x. Okay, so the square of x is going to be x squared. And it's inversely proportional to cube of t. So the cube of t is t cubed. Okay, so A gets directly proportional to the square of x. So the x squared is going to go in the numerator along with the k. And in the denominator, we're going to have t cubed because so inversely puts it in the denominator. So that's going to go in the denominator like that. So kx squared over t cubed. Yeah, by the way, I appreciate you guys asking questions. So if you have any trouble with anything, please ask a question. Okay, let's do number 8. A is directly proportional to x and inversely proportional to t. Okay, so what's going to happen there is the x goes in the numerator and the t goes in the denominator like that. Okay, and then the second part is use the given information to find the constant of proportionality. Okay, if x equals 4 and t equals 2, then a is 16. So you take these numbers and you just plug them in. So the a gets replaced with a 16. The x gets replaced with a 4 in parentheses, and the t gets replaced with a 2. Okay, so that means that 4 divided by 2 is 2. That's 2k is 16, which means that k is 8. Okay, so 8 will be the answer. Okay, next problem, number 9. Express the statement as an equation. So r is inversely proportional to the square root of x. Okay, square root of x is going to be this, square root of x, like that. Okay, inversely means the denominator again. Okay, so r is, and then there's nothing else, so r is equal to k over the square root of x. Okay, so that should be the answer to the first part. Okay, second part, use the given information to find the constant of proportionality. If x equals 169, then r is 0.5. Okay, so this r gets replaced with a 0.5, and the x gets replaced with 169. like that. Okay, and then just solve for k. So let's see, 0.5 is actually 1/2, and the square root of 169 is 13. Multiply both sides by 13, and k is 13 over 2. Okay, number 10. The cost of printing a magazine is jointly proportional to the number of pages, P, in the magazine and the number of magazines printed, M. So cost is, or cost equals, and this jointly proportional means that everything's going to be in the numerator. No, it doesn't say inverse anywhere, so that doesn't. Inversely means it doesn't put anything in the denominator. So it's going to be k times the number of pages times the number of magazines, M. So P and M, or small p and small m, this is a capital C, is going to be the equation. This kind of makes sense because the total number of pages is actually going to be the number of pages times the number of magazines, right? So if a magazine has 10 pages and there's 50 magazines, then that's going to be 10 times 50, which is 500, right? 500 pages. Okay. So anyways, C is equal to KPM for the first part. Part B, find the constant of proportionality if the printing cost is 41,440 for 3,700 copies of a 112-page magazine. Okay, so here we put in 41,440 for C. So this C gets replaced with that. The M gets replaced with 3,700, and the P gets replaced with 112. So P is the number of pages, so that's 112. And M is the number of magazines printed, so that's 3,700. Okay, so divide both sides by 112 times, and also by 3,700. Okay, I ran this to a calculator, and I got 0.1. It worked out to exactly 0.1, which is nice. Okay, and then finally, part C, how much would the printing cost be for 2,000 copies of a 72-page magazine? Okay. So this is our original formula. We know that K is 0.1, so let's put a 0.1 there. And 72 pages, that would be P was 72, and 2,000 copies, M was 2,000. And this works out to $14,400. Okay, any questions on any of this so far? Okay, let's move on to number 11. The resistance of a wire varies directly as its length L, and inversely as the square of its diameter. Okay, so the square of the diameter is going to be d squared. Okay, write an equation that expresses the joint variation. So the resistance of R varies directly, so R equals, so put a K in there. Directly as the length, that means L is in the numerator. Inversely as the square of the denominator, so D squared is in the denominator. Like that. Okay, part B. Find the constant of proportionality if a wire 1.4 meters long and 0.005 meters in diameter has a resistance of 110 ohms. Okay, so this is R, is the resistance. This is L, this is D. So we plug those numbers in. So R is 110. This R gets replaced with 110. K is still there. That's what we're trying to find. L gets replaced with 1.4. And D gets replaced with 0.005. But it's squared, so it's like that. Okay, so if I divide everything over to the other side, okay, this 1.4 goes down in the numerator, like there. 0.005 squared goes up into the numerator. Oh, wait, I'm sorry, 1.4 goes to the denominator, like that. And it says, the instructions say round to 6 decimal places. So I put this in the calculator. And rounding to 6 decimal places, I got 0.001964. Like that. Okay, so part C. Find the resistance of a wire made of the same material that is 4 meters long and has a diameter of 0.008. Okay, so our L is 4 and our diameter D is 0.008. Okay, so now what we have is this is our K. So we can go ahead and put that K right there. Okay, now L here is 0.008. And wait, no. L is 4. So there's a 4 right there. Okay. So this L is 4. The diameter is 0.008. Okay, so 0.008 goes down here. But it's squared because it's squared in the formula, and it's squared right here. Okay, so I put it in the calculator, and I got approximately 122.767857 something like that, okay? And the instructions say to round it to the nearest whole number. So then since this is 7, which is greater than 5, greater than or equal to 5, then I'm going to round this up to 123. Okay, then finally, the last part, if the diameter is doubled, okay, doubling means you're going to take the diameter and go from D to 2D. Okay, if the length is tripled, that means you're going to take the length and go from length to 3L. By what factor is the resistance changed? Okay. So here we have the formula. There's the original formula. And then after applying this process, let's have the same constant, but the length is tripled, so that's 3L right there. And the diameter is doubled, so that's, so the new diameter is 2D. That's 2D squared. Okay, so that's going to be 3KL over 4D squared. Okay, so notice that the original resistance is right there. Okay, so that means that the factor is 3/4. Okay, so that means that the factor is that it's changed by is the other part right here. So 3/4 is the answer.